In this video, we're going to extend out the idea of rational numbers to look at how to write rational numbers as fractions. So if you're curious as to where this comes in the standards, in fourth grade, we're going to look at using decimal notation and writing those decimal numbers as fractions. And then in fifth grade, we're going to look at writing whole numbers as fractions so that we can multiply a fraction or a whole number by a fraction. In sixth grade, we're going to look at multiple representations of rational numbers, so moving fluently back and forth between fractions and decimals. And also in sixth grade, we're going to introduce the idea of percentages. And then in eighth grade, we're going to look at those repeating decimals and changing those types of numbers to fractions. So you can see that we have all four of our different types of rational numbers represented. Okay, so let's start here. Let's look at writing integers as fractions. So this one, to write an integer as a fraction, you basically take whatever the integer is and put it over 1. Oh, that looks horrible. Let's try that again. Whatever the integer is and put it over 1. That looks better. So it doesn't matter if your integer is positive or negative or 0. You do them all the same way. This one tends to give my students the most problems. So with our trigonometry unit that we're working on right now, for example, if we know that the sign of a number is 0, I need to be able to write that 0 as 0 over 1 so that I can take the reciprocal of it to find cosecant or secant or whatever the trig function is that we're working on. However, they stumble over the fact that 0 divided by 1 is 0. So you might want to emphasize that with your students because I know that one is one that just causes problems as they move forward. I will also say for you guys, these are probably easiest. For your students, this is a mind-boggling concept. I was not prepared for that when we were homeschooling and we were talking about multiplying fractions and I said you just change your whole number to a fraction and then you multiply and their little eyes got wide and they looked at me like, what are you talking about? So we had to pause, we had to draw some pictures, look at some other representations, and then they got the idea that any whole number or any integer written over 1 is the way that we would express that integer as a fraction. So just don't take that for granted when you start working with your students on that. It's a little bit more challenging for them than you might expect. Okay, the next type of number we have, fractions, can be written as fractions. So I understand that fractions already are fractions, so I wanted to look at a couple of mixed numbers and to make sure that we were comfortable with changing mixed numbers into fractions. So you remember a ratio is two numbers compared by division, and in a mixed number, I have three numbers. So I want to change this from being 1, 2, 3 numbers to being 1, 2 numbers. So the way I'm going to do that is I'm going to take my denominator, multiply by the whole number. 4 times 5 is 20. And then I'm going to add the numerator. 20 plus 3 is 23. So this is going to be important when you guys get to 292. I just thought it would be good for you to see that as a reminder so that when you go to work with those kind of things, it'll be a little bit more fresh on your memory. All right, negative numbers sometimes cause people problems because you think maybe I'm going to do 3 times negative 2 and then then add my numerator of 1, but that's not the way this works. Basically, you just ignore the negative completely. You multiply 3 times 2 and add 1 and then put the negative back on there. So if I look at this, 3 times 2 is 6. 6 plus 1 is 7. So my fraction is going to be 7/3 and then I'm going to make that negative. So that's how you're going to change a mixed number into an improper fraction, regardless of whether your mixed number is positive or negative. All right, the next kind of rational number that we're going to be looking at are terminating decimals. Terminating just means come to an end, and you can see that 5 and 1300ths right here comes to an end. Negative 2 and 347 thousandths comes to an end. Now, technically, it never ends. Technically, there is an infinite number of zeros after this. And so they will talk about in the standards that the decimal expansion is always never ending. It's just that sometimes what it never ends with is just zeros. And when that happens, we call these terminating decimals. And we say that they end right here. So if I want to write this terminating decimal as a fraction, basically if I can read this properly using appropriate terminology, I can change it into a fraction based on my words. So this is 5 and, so I'm going to put my 5, 13 hundredths. Well, 13 hundredths is written like that. So again, if you think about what the words are, that's going to help you change your decimal into a fraction. And then if I want to, I can change this mixed number into an improper fraction, just like we did before. 100 times 5 is 500. 500 plus 13, 513 over 100. So that is my terminating decimal written as a fraction. All right, let's try this one. And just like before, that negative doesn't really affect the way we do it. The negative just kind of comes over with it. So this is -2 and, so let me put my -2, 347 thousandths. So 347 thousandths. Reading it properly, practicing with that place value is going to help me write my fraction correctly. And now I can change this mixed number into an improper fraction if I want to. 1,000 times 2 is 2,000. And then I'm going to take that 2,000, ignoring the negative, and add it to 347. 2,347 over 1,000, and then I'll make my fraction negative. The negative does not affect the process of changing the mixed number into an improper fraction. All right, the last kind that we have is repeating decimals, and I'm going to do a couple of those because I think those are the ones that you probably have the least experience with. You perhaps have forgotten this from when you were in middle school. So 4.6 repeating. I think we can agree that that's the same thing as that. My dot, dot, dot on the end there, my ellipses, meaning that it goes on and on forever. So in order to change this repeating decimal into a fraction, I can't just put it over 1,000 like I did before because I wouldn't be able to figure out how many zeros went. Because it goes on and on forever, I would need an infinite number of zeros, which is not possible. So I need some other way of working with this. Well, it would be great if I could get that infinitely repeating part to go away. Like that would help me a lot. So let's call this number n, and you'll be able to see why this is an 8th grade concept. You need a little bit more math experience. So do you see that after the decimal, I just have 6's repeating? Well, if I multiply by 10, and the reason I'm choosing 10 is because I have one number after the decimal that's repeating. So I'm going to put 1 0 here. I'm going to shift everything one place value. So 10n is 46. If I have an infinite number of 6's and I scoot over one, I still have an infinite number of 6's. So the part that's behind the decimal in this number and the part that's behind the decimal in this number are exactly the same. So if I set it up with the larger one on top, right? So there's 10n, and here's my original n. N is the same thing as 1n. And then what I'm going to do is I'm going to subtract those. So 10n minus 1n, that's 9n. Now look what happens after the decimal right here. I have an infinite number of 6's right here. I have an infinite number of 6's right here. So they subtract away, and I really am just focused here on the 46 minus 4, which is 42. Dividing both sides by n to get n by itself. So n equals 42 over 9. I always want to check to see if that'll simplify, so I'll use my divisibility rules. 4 plus 2 is 6. 9 doesn't go into 6, but 3 does, and 3 goes into 9 also. So I'll divide both of those by 3, and I get 14 over 3. So my original number I called n right here, and I have simplified down this number right here to be n as well, and n can only be one thing in the problem. So therefore, 4.6 repeating is the same thing as 14 over 3. I have changed this repeating decimal into a fraction, and using this subtraction process is what's going to help me be able to do that. Okay, let's look at one that has more than just one number repeating. So again, I'm going to start off the same way. I'm going to write this number out without the repeater bar so I can get an idea of what it looks like. Now, do you see this time I have two numbers repeating? So in order to make the exact same thing behind the decimal, I'm going to need to scoot my decimal 2 places. I'm going to need to shift 2 place values, which means I'm going to need 2 zeros when I multiply. So shifting 2 place values is going to give me this. And again, I have an infinite number of 2 sevens right here. So if I shift over, I still have an infinite number of 2 sevens, right? 2 7 repeating infinitely. It doesn't matter if I have one less, you still have infinity. So now I have the same thing behind the decimal here that I have here. So I'm going to use my subtraction idea. I'm going to put the larger one on the top. And just for space, I'm going to only have 1, 2, 7 right there. I'm going to run out of space. So when I subtract, just like before, I have infinite 2 sevens on the top and the bottom. So they're going to subtract away. And I'm going to have 324 on the right. 100n minus 1n, 99n. Dividing both sides by 99 as before. Okay, so let's see. 324. 3 plus 2 is 5. 5 plus 4 is 9. So I know 9 will go into this. I know 9 will go into 99 11 times. So let's divide out that 324. This will give us an opportunity to practice with our division. 9 goes into 32 3 times. 27, and then I'm going to subtract. 9 goes into 54 6 times. I'll just put my 0 over there again for time space. So the answer to 324 divided by 9 is 36. Now look at 36 and 11. 36 is divisible by 3 and 2, but 11 is prime. It's not divisible by either one of those. So I have simplified down as far as I can. So my original n was here. That same n, I have just rearranged it as a fraction over here. So now I know that 3.27 with a bar on it is the same thing as 36 over 11. I have written this repeating decimal as a fraction because anything I can write as a fraction, I know is rational. Now, there are lots of other ones you can do where you have more numbers repeating, or you have some where only part of the number is repeating, and I'm going to save those for 292. I just thought it would be good for you to get a reminder, kind of get this in your brain so that when you see it again in 292, it won't be quite so overwhelming.